Can you see this? Okay.
Yes.
All right, good. Well, I think all of the three speakers actually talk about the necessity of the CCUS. I'm very happy with that. I'm in academia and doing research work for CCUS, and talking to the industry and government. We need CCUS technology development in Kazakhstan. So today I'd like to show you some experimental and simulation results, what we are doing in academia in Kazakhstan for the development of CCUS technology. This is not specific, but brief. Anyway, everybody knows that this graph is quite, interesting. So Kazakhstan, the total greenhouse gas CO2 emission, it is blue. And then, as you can see, Kazakhstan already ratified the Paris Agreement in 2016. So we need to reduce the emission of CO2, greenhouse gas. Interestingly, you can see the yellow line here, which is nationally determined contribution 15. And red line is NDC 25. As you can see, Kazakhstan already exceeded NDC 25 2011. And for the NDC 15, it is 2016. So we need to do something, unless we need to pay. So I actually joined Nazarbayev University 4 years ago. I have done this research topic in Korea and United States. So most of the CCUS at that time back then, it was mostly marine carbon sequestration. Well, anyway, we can just simply disintegrate our carbon capture and storage portion and the carbon utilization portion simply. So carbon utilization, it has been done in chemical engineering field, carbonation and conversion of the CO2 to useful chemicals. Well, even 100 years ago, the chemical engineer, chemist already have been done for this one. But problem is we cannot actually convert all of CO2 produced, emitted on the earth. So we should do carbon capture and storage. So as you know, we can capture the CO2 from the industry. And then we also need to transport, just to capture and transport it to the storage site. Well, Kazakhstan, there is a good storage capacity site in West, and there is industry, eastern part. So transportation technology is also important. And finally, there is CO2 stored permanently in proper geological formation. So the marine sequestration is not that good idea in Kazakhstan. So mostly Western Kazakhstan, empty oil well might be a good target for the CCUS business. So our research group and my colleague in Nazarbayev University working, investigating the possibilities. So here, we just divided by 4 sections. The first one, we just want to estimate the CO2 storage capacity in Kazakhstan. And then we want to estimate the quantity, quantifying the CO2 storage capacity in Western Kazakhstan oil field. And then we just take some sample from that site and then do some simulation. So what's going on over there? So how the CO2 sequestration change the geological formation. So we want to simulate, we want to do some, conduct the experimental verification so that the CO2 sequestration is safe in Kazakhstan. So using experimental task, verification, and also computation simulation. And then there is one interesting stuff in Kazakhstan. There is empty oil well everywhere. So you may have heard about the enhanced oil recovery. So instead of the gas or water, if we can inject CO2, it could be kind of both satisfy both objectives. So sequester safely CO2 greenhouse gas and also EOR case. So we just check it out. This CO2 EOR process is sustainable and good enough for the our CCUS strategy. So we conducted LCA for the feasibility of this CO2 EOR in Kazakhstan. And also, we did some carbonation. That is one part of the CO2 utilization. Because the carbonation kinetic is very slow, we do some modification and also optimization of some important operation conditions so that we can develop the enhanced carbonation process for the CO2 sequestration. I just briefly talk about the some relevant results we have done. So for the storage capacity, we just check 6 sedimentary basins in Kazakhstan. We evaluated this basin by 15 criteria with 3 categories: storage safety, capacity, and feasibility. And also 104 major industrial CO2 sources actually considered, mostly 6 industrial sectors in Kazakhstan: power, oil, gas, metallurgy, chemical industry, mining, construction. So here, what you can find is the Caspian Basin is the most suitable for CO2 storage, the highest. And then in the order of Mangi-Shekelak and South Torgai and the Ust-Turt basins. The estimated storage capacity of this basin in Kazakhstan is almost 539 gigaton. The current annual greenhouse gas emission of Kazakhstan, which is 400 megaton. So based on this emission rate, Kazakhstan has almost the 1,400 years of CO2 storage capacity. So which means Kazakhstan is a wonderful place for CO2 storage. Here, this is kind of simulation of the CO2 injection into Western Kazakhstan site. So here we inject, and there should be some reaction by the CO2. So the CO2 carbonic acid can dissolve the minerals in that geological formation, and then another minerals can be formed. And also porosity and the permeability change and the fate of CO2 can be changed. So it could significantly influence the storage of CO2. So we actually do this using some samples in laboratory, using the some experimental system, core plotting system, and also we are using some geochemical and hydrogeological softwares. So here, the main research objective is identify mineralogical alteration and investigate the reaction mechanism, and also determine the change in porosity, which related to the fate of CO2, and calculate supercritical CO2 amount injected. We just choose one popular reservoir, Ibayati reservoir in Caspian Basin. So we are using all of these samples, and we actually take out some important parameters using this experimental setup. And then what we have done so far for the LCA of CO2 EOR in Kazakhstan, this is quite interesting. Many countries actually doing CO2 EOR, including Saudi Arabia and the United States. So EOR usually increase oil recovery from not right now 30 to 35% to 50 to 60%. They usually inject water gases, but we just want to change it by CO2. So one good thing for CO2 is, well, it could be stored as for the CO2 sequestration, but CO2 act as a solvent and reduce oil viscosity. So oil move easily to the production well, which means it could enhance oil recovery. And also the CO2 used for this CO2UR, it can be captured from industry. So this is how we estimate using LCA scheme. So here upstream and downstream and the CO2UR. So we just calculate from upstream cradle to gate. The CO2 emission is almost 180 kilogram, and also downstream 472. And from the gate to gate CO2UR process 117. So the total net greenhouse gas emission is almost 700 kilogram. But if we just offset by the electricity displacement, we can reduce it by 306 kilogram. So you can see here, if you are just using LCA and calculate the CO2UR usable case.
Sorry.
All right.
So you have literally 1 minute left.
Okay, good. So the common emission is 500. By the electricity displacement, Kazakhstan actually show 300 reduced by 357, United States 450. So Kazakhstan is quite, first stage. So we can have quite advantage when you do CO2UR based on the LCA results. And this is what we are doing for the enhancement of the carbonation using the CO2 capture and also using slag from the industry and then make cement for the construction material. We are actually enhancing, developing this chemical engineering process. So based on what the researcher and what the speakers here today, I can see the future of Kazakhstan CCUS. So for the development of technology, I believe more big research project between industry and academia in Kazakhstan should be carried out. Yeah, well, I think this is it for today. And if you have any questions and comments, I'd be happy to accept that. Thank you very much.
Well, thank you, Mr. Li, for very elaborate and interesting and positive, optimistic presentation with all these technical layouts, and it also